Alright, ladies and gentlemen, boys and girls, we're going to look at special products today. Now look at these. These are all multiplication of binomials, and you'll look at each of these binomials and you'll recognize that the first and the second are almost exactly the same except the sign in the middle. One's a plus, one's a minus. Now it doesn't matter whether the plus or the minus is first. Most of these have the plus written first, but look at this one there. I got the minus written first, so it doesn't really matter. Some of these look a little different than the ones you're used to, but heck, it's okay. It can be a little bit different from time to time. Now, the reason why we're doing this is because we want to be able to identify what it looks like when it's in the polynomial form instead of being the binomials being multiplied. That's important because at some point we're going to stop looking at what it looks like when we take two small binomials and multiply them together to get our final answer. And we're going to start looking at, okay, how can I take this bigger polynomial and break it up into smaller pieces? Okay, so we're going to want to be able to do that. And since we're doing that, then we're going to want to be able to look at it from this direction as well. So what I'm going to do, the first one I'll go ahead and do in front of you by hand. We're going to FOIL. So first, x times x is x squared. X times minus 4 is negative 4x. 4 times x is plus 4x. And then plus 4 times negative 4 is minus 16. Now you'll notice the middle two terms here, plus 4x and minus 4x, are going to cancel out. So I'm going to end up with x squared minus 16. Okay, now what I'm going to do is I'm going to go ahead and I'm going to do the next 1, 2, 3, 4 questions by hand. I'm not going to do the last one quite yet, but I'm going to go ahead and do those 4 and check and make sure that I did it right, but I'm going to have you look for the pattern. Whammo! How about that? So I got them all there. Now see if you can look at these and find a pattern. I'm going to give you just a second to look at those. Now hopefully you've recognized that when I have the plus and minus, regardless of whether it's first or second, the minus, that the second two terms always cancel out. Right? And that should make sense because you're having an x times one of them and an x times the other, and one of them is positive, one of them is negative. So what we end up with is that the first term is going to be x times x. These first two terms times each other, which are the same thing, so x squared. The last term is going to be 4 squared. And then it's always going to have, you'll notice it's always a minus in the middle. Okay, so that's the special product. Now the nice thing about this is that now if I have something that looks like this, say it's x squared minus 25, can you tell me what that would look like if I wanted it to be a binomial, multiplication of binomials? Well, yeah, if you think backwards, then you should be able to. You should be able to say, okay, well there's an x squared, so that's x and x. And I've got 25, which is what number squared? 5 squared. And then in order for it to end up giving me this, what does the pattern of the binomials have to have? A plus and a minus. And so that's a good example of how this could actually be helpful in recognizing that difference. This is called the difference of squares. Now the products are the binomials that multiply to give you this difference of squares. Now let's look at the general form here, because I just want to show that even without any numbers at all, it still works. So I'm going to take ax times ax. So I'm going to have a squared x squared. Ax times negative b, so minus bax. B times ax, so plus bax. And then b times negative b is minus b squared. So a squared x squared, you can also write this. This is actually one of our exponent rules. If you can distribute it, you can actually also pull it out, right? That 2 could distribute, and it would give you the a squared x squared. These two in the middle, what happens to them? Yep, they cancel out. And then I still got the minus b squared. Okay? So no matter what, if you have two things where the first term is the same, oops, that wasn't supposed to happen. First term's the same, second term's the same, and then you've got a plus and a minus. It'll always end up giving you this. All right? Cheers.